Okay guys, today I'm just going to do 3 more difficult examples of trig identities. So the first step, remember, is to always separate into left side and right side. Okay, so let's remember all of our tricks. We have factoring, either common factoring or difference of squares. We have turning tan into sine over cos. If you have fractions, when you're adding them or subtracting, you need a common denominator. When you're dividing fractions, you flip and multiply. And then we have the identities. We have tan, did I say tan is sine over cos already? But also cos squared plus sine squared equals 1. And then from that, cos squared equals 1 minus sine squared, or sine squared equals 1 minus cos squared. So let's get started. Now in this case, this is where, this one's tough. Because you're looking at it and you say, okay, on the left side, so both of them are fractions. That's good because they both have a top and a bottom. So I just need to massage things until I get the tops and the bottoms to be the same. But on the left side, the top is all sine and the bottom is cos. And on the right side, it's the cos is on the top, a cos on the top, and a sine on the bottom. So that seems weird. That's not right. Also, normally when you have a sine, to change it to a cos, you need a sine squared to change it into 1 minus cos squared. And I don't have that anything here is squared. Okay. I also don't have any tans. And I have nothing to factor. There's nowhere that I can really factor. So if you're in a situation where all of those things I just said are true, you need to figure out a way to get, for example, sine on the denominator here, so that it matches the sine on the denominator. I also need to get 1 minus cos in the numerator. So how do you get something when there's nothing you can do to change that to get to where you want to go? Well, you just force it in. So the way that I can force 1 minus cos here is by multiplying this by 1 minus cos squared. Or cos theta, sorry, because that's what I want. I want that 1 minus cos theta there. But if I have if I'm multiplying it by 1 minus cos theta, I can't just do that, okay? But I can multiply it by 1 minus cos theta times 1 minus cos theta. Why can I do that? Well, that is just really 1. It's the same thing over the same thing. So this, you can put it in a different color or something like that. That's just equal to 1. So I can multiply it by 1. That's not changing its value. So that's a technique that you can use, is multiplying something, or this left side by 1, a version of 1 that suits your needs. So this version of 1 suits my needs because I need 1 minus cos theta on the top. So I'm having faith now that I can manipulate this to get to where I want to go. So I have sine theta 1 minus times 1 minus cos theta all over 1 plus cos theta and 1 minus cos theta. Okay, don't cross these off now because we just introduced them. So you don't want to cross them off because we want them there. We added them in. So what can I do now? Well, I could multiply through sine theta minus sine theta cos theta, but that really won't get me anywhere because I just want that 1 minus cos theta on the top. So that means I need to do something to get rid of that sine theta. So what happens when I FOIL this out? I would get I'm going to keep the top the same. But when I FOIL this, 1 times 1 is 1. And I get negative cos theta plus cos theta. That goes away. And then it's a minus cos squared theta. Because this is just the factorization of a difference of squares. So here it gets back to a difference of squares. So I'm going to keep the top the same again. Reminding myself that it's that sine theta I'm trying to get rid of. So how can I get rid of that sine theta? Well, 1 minus cos squared theta, what can I replace that with? Why does that help me? Well, I can replace it with sine squared theta. Aha! Well, now that I have a sine squared theta on the bottom and a sine theta on the top, I get rid of one of these and one of these. So now I'm just left with 1 minus cos theta over sine theta. And my heart feels good. Okay, so this is maybe something that's weird to you or difficult, something a bit more abstract, but it's something that's good to practice. So what you could do now is pause the video, get out a piece of paper, rewrite this identity, and now try to multiply don't touch the left side, leave the left side in its original form, and try to multiply the right side by something and manipulate that until you get it to look like the left side. Okay? Now, if you really hate this, there's one other way that you can do something like this when there's honestly nothing else you can do to move things around there or to replace. You can turn all of the sines and coses into their x and r definitions. So you can have x over r all divided by 1, sorry, this is y over r, my bad. Y over r divided by 1 plus x over r. And this would be 1 minus x over r divided by y over r. Okay? And you can manipulate this using your algebra skills until you have left side equals right side. So you would have y over r all over r plus x over r. Okay? Because I just got a common denominator there. So that would be y over r times r over r plus x. The r's cross off, so I would have y over r plus x. Here I would have r minus x over r over y over r. Okay? And then I would have r minus x over r times r over y. So in this case, I would have r minus x over y. Okay, so this doesn't make any sense right now, so how can I get this to be like that? Okay, so now you need to do the same thing, actually, where you multiply by something to get back to this, okay? Because you need to get the y on the top. So you can try that if you want to. It's a bit more abstract than this, to be honest, okay? This is a bit more difficult. I just wanted to present it to you as an option if you wanted to manipulate these a bit more. But yeah, I'm just showing you that this is another way, but it's definitely not required. So if that confused you too much, you don't even need to really write it down, or you can cross it off. All right. Here we go to this next one, okay? So we have cos squared minus sine squared over cos squared plus sine cos, and then 1 minus tan. So I always just immediately change this to 1 minus sine over cos. Now notice I don't have theta in here. Okay, that's because I'm just getting lazy and drawing the theta all the time, drives me nuts. You don't actually really need it to prove that it's true. Okay, so then I'll get a common denominator just so I have only one fraction. So I'd have cos minus sine over cos. Okay, common denominator. So that looks pretty simplified. I'm going to go to the left side now and try to work on that to make it look like this. So I feel kind of good because I have a cos squared and a sine squared on the top, and I need it to be cos minus sine. So that's a difference of squares, so I'm going to factor that. Which gives me a cos minus sine. So I'm feeling pretty good. So that just means I need a cos plus sine on the bottom to cross it off with so that I only have cos minus sine left. So I notice here, there's lots of things I could do, right? This cos squared could be replaced with a 1 minus sine squared. Wouldn't really help you because I'm trying to get only one cos squared on the bottom. So it wouldn't really help me to introduce another sine. But I do notice that there's a cos in both of these terms, so I'm going to factor out a cos, common factor. So I'm left with cos plus sine. Oh, cool! A cos plus sine on the bottom, exactly what I needed. So I cross those off, and I get cos minus sine over cos. which is what I did here. So notice that I manipulated the easier side first, and I got it to be 1 fraction. I didn't just leave it like this because I noticed that the left side was all in just 1 fraction. So I wanted to make the right side just 1 fraction, so then when I moved over there, it would be easier to get them to look alike. Okay, if I had started with this side, I might not have known where to go because there were more options of what I could do with all of these things. By starting with the more simpler side, it becomes clearer how I should manipulate the more difficult side. All right, one more, and it's a biggie. Okay, so take some time there and separate into left side and right side. Okay. So I got all kinds of things going on. Notice though, my right side is in terms of a fraction that has all signs in it, and my left side has sines, coses, and tans. So big hint here, when you have all signs, you want to turn everything into sines as much as possible. Okay, so I'm going to leave this and see what I can do here on this side. So I'm going to leave sine squared the same because I need sine squareds. And my cos squared I'm going to turn into 1 minus sine squared. Be very careful though that it's in brackets because this negative will distribute to this parentheses. And then subtract in brackets sine squared over cos squared. Okay, so I'm so close to having only sines, but I don't have only sines. It's really annoying to me at this point. So the first thing I want to do is just distribute this negative, okay? So I get sine squared and then plus another sine squared. So I get 2 sine squareds minus 1 minus sine squared over cos squared. So now I gotta actually, to get a common denominator, I have to introduce this cos squared everywhere. So I'm feeling a little bit discouraged because I was so close to having only sines, which is what I need, but now I'm gonna have to introduce this cos. But I'm gonna have faith, I'm gonna try it anyway and see what I can do. So I get 2 sine squared cos squared minus cos squared minus sine squared all over cos squared. So I just got a common denominator. So to get the common denominator, I had to multiply this by cos squared and this by cos squared. Okay, so I know that I need a 1 minus sine squared on the bottom. Oh, but cos squared, I can actually replace that with 1 minus sine squared. So I'm feeling pretty good about that. That's not so bad. And I have this cos squared that I can turn into 1 minus sine squared. And I'm already seeing something I can do here. All right? So either you can change this into 1 minus cos squared also, or you can do what I'm going to do. So the 2 sine squared is now multiplied by 1 minus sine squared. Okay? I changed that cos squared. Now I'm going to subtract and put this as cos squared plus sine squared. Because that's going to give me the 1 that I need here. The minus 1. Okay, so I feel pretty good about that I figured that out. I just common factored a negative 1 out of there. All right, and then I'm changing this denominator into 1 minus sine squared because that's what they have on the right side. So I'm pretty close. I think now when I actually FOIL, distribute all this, and change this to a 1, I think I'm there. I think I'm just about ready. I think it's just about solved. So 2 sine squared, okay, I multiplied there. And then minus 2 sine to the power 4, okay, because squared times squared is to the power 4, and then minus 1, because that's just this Pythagorean identity. And I'm looking, I think I did it, woohoo! Because I just said 1 minus sine squared. And I feel amazing. So there you have it. I did left side equals right side. Now, is this the only way to prove this identity? Absolutely not. There's many ways that you could have proven this, but this was the way that I personally used. So I think it's probably one of the more efficient ways. There's lots more ways that might have taken a bit longer, but there you go. So really the moral of the story, just like I said in the last video, is perseverance and not giving up. Just believing that there is a way to solve it. You just have to pick the right tools. Again, always compare your left side to your right side. Where am I going? What do I need to get there? And then hopefully with working through it, you'll find some success. And hopefully some of you might even enjoy it. So thanks for watching. I hope you learned lots.